Okay, for our next problem on here, notice they don't give you anything. While I was changing videos, I made myself a table. It's easier for me to organize. Carlos made 66 phone calls to gather support for a political candidate. The number of senior citizens he contacted was 3 times the number of young adults. The number of middle-aged adults was 1/2 the number of senior citizens. So how many senior citizens did he contact? All right. Well, we know the total here has to equal 66. So we're going to judge whether it's too high or too low based on that. But now how am I going to get there? What am I going to use for my guess? That's where I have to start, my guess. Well, I have senior citizens, young adults, and middle-aged. Here's how it goes. I started with senior citizens is 3 times the number of young adults. So I use young adults to get to the senior citizens. Then it says the number of middle-aged adults was 1/2 the number of senior citizens. So once I know the number of senior citizens, then I can go to middle age. So I'm going to start out with my guess of young adults. From there, I can find the senior citizens, which is 3 times the young adults. And then I can go to middle age, which is 1/2 the number of senior citizens. So this is going to be the senior citizens divided by 2. So senior citizens is based on young adults, and middle age is based on senior citizens. The total is 66. So, I don't know. Let's, just because, I'm going to start with 20. Total is 66. Well, the senior citizens is 3 times 20, which is 60. All right, well, I can tell right here, I've got to add all these up. Already I'm at 80. So this is going to not work. This is too high. I'm going to have to go lower. It was way too high, so I'm going to go back down to 10. Let's see. 3 times 10 is going to give me 30 senior citizens. Then I take the number of senior citizens and divide it by 2, and that gives me 15. So if I have 10 plus 30 plus 15, that gives me 55. That doesn't work either, it's too low. So, I don't know, let's pick something in the middle. Let's see. 20 was way high, so it's probably closer to 10. I don't know. Let's pick 12. 3 times 12 is 36. 36 divided by 2 is 18. If I have 12 plus 36 plus 18, I have 66. So the answer to the question is, how many senior citizens did he contact? He contacted 36 senior citizens. The hardest part on this kind of problem is figuring out where to go. Where did you start on this? And just so you'll have it as a reference, I'm going to go ahead and fill this in. 60 divided by 2 gives me 30. And when I add all those up, this gives me 110, which is just too high. Okay. All right, now we did do this in class, so I'm going to go back over it very quickly. Order of operations, you've probably heard since maybe some of you heard PEMDAS. I didn't hear that until I started teaching. But it expands a little bit. Parentheses actually become grouping symbols, which can be parentheses, brackets, braces, absolute value, and fraction bars. you have to do everything above, everything below, and then do your division. And this is going to be real important when we're starting things. So say, for example, you have like 5 times 3 plus 7 divided by 12 divided by 4 minus 8. You would want to do all of this and then divided by all of that. And that's probably how you would enter it in your calculator. Okay, so for the exponents, you want to simplify them first. You know what taking it to a power. Remember that a to the n is a times itself n times. So for example, 3 to the 4th is 3 times 3 times 3 times 3, which is 81. Multiply and divide, these have the same weight. They are the same operation. So you're always going to go from left to right, and you might have to divide first. Adding and subtracting, same thing. They're basically the same operation, so you're going to want to go from left to right, and you might have to subtract first. Now, one of the hardest expressions when I teach algebra is to impress upon students that these two things are not the same. And one of the ways I do it is I try to show them that they are not the same by providing a counterexample. And the difference is the order of operations. The one on the left, first I have to do the inside parentheses, which is the addition, and then the exponent. This one here, I have to do the exponent first, and then the addition. The difference here is that the addition is not grouped together, it is here. Now, I claim that they're not true. So let's do a counterexample, and let's just pick numbers. I am going to pick x equals 5 and y equals 3. So for this one here, I would do 5 plus 3 to the second. I would have to do the addition first, so this would give me 8 to the second, and 8 times 8 is 64. Here, if I have 5 to the second plus 3 to the second, 5 to the second is 5 times 5, which is 25. 3 to the second is 3 times 3, which is 9. And now when I add those together, I get 34. They do not express the same number. So you did prove that the statement is false. If you say something is always true, if you can find one counterexample, that means that it's not always true. And sometimes it's easier to find than others. There are a lot of counterexamples on this that are really, really easy. Okay, that is the end of 1.5.